Assalamualaikum viewers. Today we are going to discuss about homologous series and its importance basically. We know that we have over 10 million organic compounds in organic chemistry, and study of those organic compounds one by one is a very difficult process. So first phase after the announcement of the functional group was the classification. We have classified organic compound into different families, and what was the base of that classification is functional group. So basically we have classified organic compounds into different families or classes or groups on the basis of similarity in functional group. So when functional groups serve as a base for classification, then a hydrocarbon portion remains a predictable portion in organic compound. Whenever we write the general formula of any class, say I have written ROH. ROH basically a general formula that belongs to alcohol class, in which OH is the functional group, whereas R portion is basically the hydrocarbon portion, alkyl group, which is attached to that OH group. Now this R represents the hydrocarbon portion to an organic compound. So when we talk about the class of alcohols, say, then all the hydroxyl group containing compounds which have varied number of carbon atoms, they have been listed in this alcohols family, and they all have similar OH group in them. Variation is R group. For example, iodide, simplest of the alcohol is a 1 carbon alcohol in which R group contains 1 carbon atom in it, that is CH3OH methyl alcohol. Next it is a 2 carbon containing alcohol, that is C2H5OH. Next it is a 3 carbon containing alcohol, that is propyl alcohol. Next we have a 4 carbon containing alcohol, that is butyl alcohol, and so on. Now look at these structures. One thing is very common, that they all have a common functional group, that is hydroxyl group. But the varied portion is the hydrocarbon portion. In first compound we have 1 carbon atom, in second compound we have 2 carbon atoms, in third compound we have 3 carbon atoms, and in fourth compound we have 4 carbon atoms. So if you notice all these, then each compound differ from the other by a specific portion, and that specific portion is basically a CH2 unit or a CH2 group. This CH2 unit or group is termed as methylene group. This is methylene group. Now looking at these structures, one thing very observable is that CH3, that is methyl portion, and C2H5, that is ethyl portion, they are differing from one another by a CH2 unit. Similarly, this ethyl portion and this 3 carbon atom propyl portion, they both are again different from each other by a CH2 group. That is, this CH2 group is not available in that structure. This CH3 and CH2 is also available in the above structure as well. Now, if we look at the last and the third structure, then this third and fourth carbon atom, again, they are again different from each other by a CH2 unit. Now, looking at these structures, one thing is very observable, that each organic compound in the series is now different from the other by a CH2 unit. Such type of series, like we have written for alcohol over here, in which all the compounds are different from each other by a CH2 unit, and by knowing the one of the compound, we can predict its either preceding or succeeding organic compound both. So such series will be termed as homologous series. So basically, homologous series is a series of organic compound in which similar functional groups containing compound are arranged in such a way that each member differs from the other by a CH2 unit. Such series, such arrangement is termed as homologous series. Look again, a series or an arrangement of similar functional group containing organic compounds in which each member of the series differ from the other by a CH2 unit, this series will be termed as homologous series. Now, this homologous series establishment has made the study of organic compound so easier that we have limited the study of over 10 million organic compounds into almost 27 different homologous series. So, study of the organic compound that have shrunk from 10 million to just 27 families, because in the previous lecture we have seen that this functional group is basically a base of chemical reactivity. So all these four compounds which have a difference in their carbon number but all have an OH group attached, a functional group, similar functional group attached to them, so they all have similar chemical characteristics. So study of the organic compound by adjusting different organic compounds into homologous series has made the study easy. Major benefits of arranging organic compounds into homologous series is: number one, they have same functional group. Now look, when they have same functional group, then we can say that number two, they have same chemical properties. When functional group is same, then their chemical properties are same. So we need not to study the chemical properties of all these compounds again and again. But looking at the functional group, we can say that their chemical behavior will be alike. Number three, due to difference in the carbon number, what happens is basically a change in their molar mass occur. CH2 unit has a molar mass of 14 grams. So if methyl alcohol have molar mass of 12 plus 3 plus 16 plus 1, that is 16 plus 3, 19, 20, and this becomes 34 say. Now CH2 has a molar mass of 40. Molar mass of this methyl alcohol is 32. Now when we add a molar mass of CH2 unit, that is methylene unit, into it, then 32 plus 14 should be the molar mass of next compound, that is ethyl alcohol. So when the molar masses of all these compounds are varying by a specific margin, that is 14 gram per compound, then we can predict their physical properties as well. Not exact location, but prediction can be carried out. Prediction and their physical properties can be carried out, because physical properties varies due to difference in their mass numbers. Number 4, they have same general formula. They have same general formula. For example, we have written the alcohol family over here. So all the alcohols are represented by a general formula, that is ROH. Now the R group varies. For 1 carbon atom, R group is methyl group. For 2 carbon atom, R group is ethyl group. For 3 carbon atoms, R group is propyl group. For 4 carbon atoms, R group is propyl group. So variation in the R group, that is alkyl group, happens, but the general formula overall remains same. So all these features are enabling us now that we study the limited number of different series of organic compounds rather than studying the entire 10 million organic compounds one by one. So this establishment of homologous series has made the study of the organic compounds very easy for us, and we can predict the behavior, the prediction methods, the physical and the chemical behavior of all the organic compounds. And lastly, if we know how to prepare one of the organic compound of a given homologous series, then we can prepare rest of the members of that series by the same method. So we can say that they have same preparatory method or same preparation methods. Just like if someone knows how to make a one chair, then he can basically make so many chairs using that methodology. Likewise, if we know how to prepare, say, methyl alcohol, just by adding the carbon numbers into it by a carbonization process, we can form 2 carbon alcohol, we can form 3 carbon alcohol, we can form 4 carbon alcohol. So these are the general features which we obtain as a benefit by listing the organic compounds into different homologous CSs. Thank you for watching.